Welcome everybody. This is our 750 economic growth, and today we're going to study unified growth theory. So far in this semester, we looked at models of growth and also some models of poverty traps. Now, the idea of unified growth theory is to unify these two mechanisms, right? So, historically speaking, we observe today's developed economies actually were stagnating for long centuries, okay, in some sort of a Malthusian equilibrium. Of course, there are certain differences across the countries in terms of the Malthusian experience, but generally speaking, before industrialization, countries were poor in modern standards. So this theory, which is called unified growth theory, was first explored or discovered by Gallor and Weil in 1999, and 2000 paper in American Economic Review is actually the seminal paper. Then Odette Gallor was actually more active in pursuing this theory, and the 2005 version published in Handbook of Economic Growth is actually the most elaborate version of it. And finally, in 2011, Gallor collected his studies within a book which has the same title, Unified Growth Theory. So the main purpose is to explain, and this is somewhat ambitious as you see, develop a single model to explain all three regimes, okay? Malthusian stagnation, modern growth, and the transition between these two regimes. And we want to do that without requiring big exogenous shocks. So that's important. So of course, in a Malthusian model, if you hit the model with certain shocks, if you are particularly engineering the model, right, and if you put some big exogenous shocks, you may create some growth. But we don't want that. There is this famous dictum that nature does not make leaps, right? So nature does not jump. So what we observe in economic history largely confirms this message. So we see gradual changes in certain macro aggregates, such as population and other stuff. Of course, there are shocks, and some shocks are exogenous, such as the Black Death, for instance. But even there, we want to understand the aspects creators, I mean, the consequences of such shocks in a manner consistent with our typical modeling approach, because we want to endogenize stuff. So we want to analyze within the unified growth theory, we want to analyze this transition, the transition from stagnation to post-Malthusian era, and then post-Malthusian era to modern growth, in an endogenous transition and a gradual transition. Okay? So it must not be an exogenous shock, you know, the Industrial Revolution, for instance, or it must not be a big shock, all right? So there must be endogenous changes and gradual changes. Let's define these regimes first. In the Malthusian regime, incomes are low, consumption is fixed at subsistence, and fertility is increasing with income. So this is the Malthusian model that we studied, actually, right? In that Malthusian system, if incomes are sufficiently low, and if people are subject to some subsistence consumption constraints, remember that it looks like something like this, right? So consumption must be greater than some fixed number, okay? Now, in such a system, then if kids are normal goods and if consumption is at subsistence, we will see that fertility will be increasing with income. Okay, so these are the typical features of the Malthusian regime. In the post-Malthusian regime, incomes are high enough to imply consumption above subsistence, right? So we have, so if we have CT equals, let's say C tilde here, so this is subsistence. Here we have CT greater than C tilde. Okay, when that's true, fertility is no longer depend on income. Okay, so here fertility, let's say NT, depends positively on income. Here, so let's divide these regimes. Okay, here fertility is independent of income. Okay, what does it mean? Increased income is directed to consumption, and you're going to see why. And finally, there comes a regime which is called the modern growth regime. Here, the demand for human capital is sufficient to large, so that's important. Human capital. Okay, so in this model, we're going to have quality quantity trade-off. Oops. Okay, just a sec. Quality quantity trade-off. Okay, so people start investing in the quality of their kids and they start decreasing fertility. Okay, and this is modern growth regime because when human capital is larger, then growth rate will also be faster. Okay, growth rate will also be larger. So that's the idea. That's if you think about it, that covers the entire human history. How? Well, let me show how. This is England. Okay, so on the left, you see log of population. Okay, this one. And on the right, you have log of real GDP per capita. And if you look at the horizontal axis, this is like 7 centuries. Okay. Now, if you carefully distinguish regimes in England, you see this result. So the blue one is roughly the Malthusian regime. Okay. Maybe I can do this. Oops. Okay. So the blue one is the Malthusian regime. So let me show you certain stuff here. So this right here is the Black Death. Okay. Now what happens? Population decreases. So this is of course logarithmic. That's important. Be careful. So this is all smoothed out. So here, as you see, Black Death creates that increase in real GDP per capita. Now, as you also see, population recovery takes centuries. Okay, so this is the pre-Black Death level, and population in England returns to that level here in the beginning of 17th century. Okay, so it's a very, very long recovery. And during that recovery, there are certain fluctuations, but there is no overall growth, right? So if you compare, of course, this level with this one, there is some trend growth, right? So there is on average some growth here, but there is no huge break. So most of this, as you see, is associated with the like that, right? Most of this increase. So most of this increase is actually associated with black debt, and some part of it is associated with some growth factor. Okay, and we will see what is it. Now, at this point, post-Malthusian regime starts, the pink one. Why? Because before that, after that point, there is no population crisis. Right? Malthusian regimes are typically characterized with population crisis, such as this one. Okay? And the last one is actually here. Okay, very, very small decrease in population because 17th century was a bad century for both agricultural productivity, climate, and certain mortality crisis. And as you see in the post-Malthusian regime, we also observe, so population is getting increasing, and also there is some growth in income, okay, real incomes. But here, there is no decrease in fertility, okay? How can we distinguish the modern growth regime? Well, there is this change of the derivative, as you see, right? Because this regime requires fertility to decrease, human capital to increase. And as you see, there is a fastening of the growth rate, okay? So the growth rate here, look at the trend growth rate here. So let me change color. Let's make it blue. So there will be a trend growth rate here, right, in this regime. What is it? So it's like that. Oops, sorry. So it's like that, right? And then there is also a trend here. As you see, growth rate here is faster. Okay? So when we look at this figure, we understand that this is the Malthusian regime. This is the post-Malthusian regime, and this is the modern growth regime. Okay, similarly, this is the Malthusian regime. So 1, 2, and 3. Okay. Now the question is, of course, how we can understand that. Now, before unified growth theory, there are, of course, certain theories and certain approaches that study the transition. Now, one interesting paper is by Goodfriend and McDermott. These economists showed that there exists actually a critical mass of population that makes industrialization efficient. Okay, so the idea is this: a country, an economy does not industrialize because the markets are so small. Okay, so it is not profitable to switch from primitive technologies to industrial technologies. But once the market is large enough, then it is easier to cover the sunk costs and transition takes place through industrialization. In Tamura, he extends the Becker-Murphy-Tamura model we studied, remember, high fertility trap model, and he studies the transitional dynamics from high fertility to low fertility. There is also Arifovich et al. In this model, there is adaptive learning. So this is an evolutionary model, actually. And the adaptive learning eventually triggers the takeoff. Okay? And finally, we have Ajamoğlu and Zilibotti. So they explain, so in this paper, this is a very nice paper, by the way. I would strongly recommend you to read it. Very, very, very nicely executed paper. The idea is this: if financial system is not very developed, okay, as in the early stage of economic development, then you cannot diversify risk. And industrialization requires big investments, but you cannot finance those big investments because you cannot diversify risk. Okay, nobody is big enough to bear the burden of financial risk. For this reason, big investments cannot be realized. So industrialization is delayed. Okay, but these ideas do not give us what unified growth theory delivers. Okay, because in the unified growth theory, we are at time zero, we hit the start button, and eventually the history progresses, the economy endogenously and gradually leaves the Malthusian trap. And then after certain generations, after a certain number of generations, the economy again endogenously and again gradually leaves the post-Malthusian era and transits into modern growth. Okay? So these four ideas are important. They are not incorrect. They are actually true, but we want to understand all of these things within a single unified model. So I'm going to go over certain details, not too much of technical detail. The model can be easily solved, and there is a computer application as well developed by Niels Peter Lagerlöf. I'm going to show you some graphs from his paper, but let's discuss the fundamentals. So time is discrete. There is a population motion here. So L is the number of adult people, and T is the fertility level. So there are two generations basically, right? After the end of adulthood, adult people die, and their kids become the next generation adults. Okay, so adults care about three things. One is their consumption, the other is the number of their children, and HT plus 1 here is the human capital of these kids. Okay, and human capital of the children will be created by the parents themselves because they're going to educate their kids. I mean, you may imagine that there are schools, that's also possible, but the model remains an abstract model in that sense. So we're not gonna create teachers or other stuff, but parents will spend scarce resources to educate their kids. This is the subsistence constraint. So consumption must be greater than or equal to some positive number. Okay, so C tilde is a parameter basically. So it's you may imagine this as a biological constraint or as a cultural constraint, because consumption has a cultural aspect of it as well, right? Because consumption is a source of status building, right? So you may imagine certain social and cultural factors as well, but most simply, it is the biological constraint. So the minimum number of calories you must take to remain alive. Now, production technology is very simple. So this is a Cobb-Douglas production technology. So H is labor here. This is the notation in this paper, by the way, Gallor 2005 in Handbook of Economic Growth. AT is the productivity variable, which will be endogenous. So this will be an endogenous growth model, okay? And X is natural resources. X is fixed, okay? Now, human capital depends on total labor endowment divided by the number of people, right? So in that sense, uppercase H is the total human capital in the economy. And X is effective resources per worker. Okay, so X is the resources per worker. So X is the amount of resource the economy has. Okay, L is the number of workers, so X over L is the resources per worker. If you multiply it by AT, it is effective resources per worker. So production per worker or output per worker is this. So output per worker depends on how skillful these workers are, H, and how much resources they have, X. Okay. For wage, we give the average product per effective skills, right? Per effective labor. So there is, of course, that type of return argument, right? So real wage is decreasing in the supply. Okay. And finally, Z is income, right? Because if I supply 1 unit of H, I obtain W units. If I supply H units, I obtain, as an earning, I obtain W times H, right? So simple. So this is typical micro theory. Now, important thing is the budget constraint, right? Why? Because they're gonna maximize this utility, right? Under some constraint. So the subsistence, the budget constraint is very simple. What do you see here? This is income, right? WTHD. So income must be greater than or equal to consumption spending and the time cost of children. Okay, so this is the time cost of children. You have NT kids, right? So you have NT kids. For each kid, you make 2 time investment. This is nursing, and this is education. Okay, so you need to take care of your kid. Now you have to spend some time for eating, sleeping, you know, other stuff. In general, it's called nursing, and also you need to educate them, and these are time. Okay, so if you have 1 unit of time, you can spend your entire work to labor market and you can obtain this income, or you spend tau plus E units for each kid, right? Then this becomes your labor supply and this becomes your total earning. Okay, so you can imagine the constraint in this way as well. They're identical. Okay, and tau is between 0 and 1 because it is in terms of time. So this is budget constraint, and this is the subsistence constraint. We already defined it. The last thing we should know is this: the human capital production function. Why do we need to know that? Because utility depends on HT plus 1, right? And HT plus 1 itself depends on ET plus 1 and GT plus 1. Okay? So here the function H is left unknown, is left implicit. Of course, education, so higher education time means higher human capital, that's obvious. But why is that? Why growth rate of productivity decreases human capital? Why do you think? Why human capital is a decreasing function of productivity growth rate? The reason is that if there is fast technological progress, your skills cannot easily adapt to the new technologies. Okay, to learn the new technology, you need to have more educational spending. Okay, so if there is very fast technological progress in an economy, then the adult people's skills are not appropriate, so they need to make additional time spending for education of their kids, so that their kids learn the new technologies better. Okay, so that's the idea behind that assumption. The problem is there. We can take the logarithms, obviously, and then we maximize this subject to budget constraint and subsistence constraint. And of course, without knowing H, you cannot find the explicit solution. But I'm going to show you, you can actually have a particular H that you can work with. Now, important thing is this. You can actually eliminate consumption from the problem. So the problem becomes choosing fertility and education. In other words, quantity and quality of children, right? And this is the budget constraint. Sorry, the budget constraint is here, and this is the subsistence constraint, right? So there are different regimes, obviously. First, you should realize that n cannot go to 0 because of the logarithm, right? And then there are 4 cases: without education, and depending with education and without education, and also cases changing when lambda is equal to 0 and lambda is greater than. So the subsistence consumption constraint is binding or lack or slack. So you take first of the conditions. For each case, you find the conditions that require optimality, right? For each case, it is simple, and eventually the important ratio is this one here. The derivative of E function, H function with respect to education divided by human capital. So the value of this when E is equal to 0. So that's the important result. Of course, the derivative can take different values depending on the explicit H function. But there are, I mean, if you write an H function, you can find explicit solutions, as I'm going to show you in a moment. Once you solve the model, you realize this. So this is the total amount of resources spent on kids, right? Time resources. So this one is again nursing, and this one is education, and this is fertility. Now, this total is going to be equal to a constant if incomes are sufficiently high. Okay, so here subsistence constraint is not binding. Okay, but here it is binding. So here it is actually like this. Okay, so if WTHT is sufficiently larger, then you are out of the trap. But if it is not sufficiently large, you are in the trap. And what happens in the trap? The total amount of resources you spend for your kid is equal to that. And as you see, for any ET, which might be 0, right? NT is increasing with income. Okay, so that's the Malthusian regime here. Okay. The behavior of education is like this. So there is an implicit function again here. So and there is this threshold growth rate. So if growth is sufficiently smaller, okay, if sufficiently small, less than G hat, then people optimally choose to not to invest in the education of their kids. Why? Because technology is sufficiently less progressive. Okay, so productivity growth, remember GT is productivity growth. So if GT is sufficiently small, okay, if productivity is like that, so small g here, all right, compared to this, for instance, then education spending will be small because there's no need to educate the kids. The machines are so simple, right? There's no advanced skills required. So for this reason, there is a threshold that activates the modern growth regime, okay? So if this is the Malthusian regime, this is the modern growth regime. So as you see, there are two different mechanisms. Whether an economy is in the Malthusian regime or not depends on income. Whether an economy is in the modern growth regime or not depends on growth rate. Okay, so the model is a bit complicated in that respect. Okay. One last thing is this. Productivity growth rate depends on education and population. Why population? Well, in the very, very long run, larger populations means faster growth rate. But in the modern times, this relationship basically disappears, right? This is the scale effect that we may have discussed before. So in the very early human development until modernity, there is actually a scale effect. But after the Industrial Revolution, that effect disappears. After the Industrial Revolution, education becomes much more important for growth. Okay? So once again, G is also implicit. And guess what? There is this, for low population, there is this stable equilibrium right here. Okay? But the thing is that the economy will move like this. Okay, because population is going to be getting slightly larger. Okay, you see, this curve will shift up, and it will therefore define at some point. It will therefore define two equilibria. Okay, actually three. There's still this equilibria, right? So which one is stable here? Obviously, this one and this one, right? This one is unstable. So, but what happens? Well, population can still grow, right? So this curve will keep moving upwards and upwards. And what happens at the end? At the end, you have this. Only one equilibrium, and it is stable. Okay, so how do you understand this is actually, I mean, how do you understand the arrows here? Well, look at this. If you are here, if this is ET, GT plus 1 is here, right? Because this is that. So if GT plus 1 is here, where's ET plus 1? ET plus 1 is here, right? According to this figure. So G must, sorry, then education must grow when we are at this point. Okay? So that's how we find the arrows. And finally, let me show you Lagerlöf's parameterization. Okay, so this is actually I'm gonna give you this as an exercise. So you're gonna already do that. The idea is that there are certain assumptions about the role of population on growth rate. Okay, and if you run the model, there is actually a MATLAB code in Lagerlöf's website as well. If you run this model, you get this result. Okay, so as you see, what do you see here? Fluctuations in population in the Malthusian era, right? Increase in technology, movements in income as well, per adult income, and education is equal to 0 for long generations, and finally becomes positive. So I'm going to conclude here. Please follow the announcements in the Huzan website. Okay.
Okay.
All right. Bye bye.